Alright, Unit 5, guided notes. We're going to spend a lot of time on statistics for Unit 5. There's 4 lessons. This first lesson should probably take 2 15-minute videos because of the material and vocabulary that's a part of it. So we'll do the best we can and get through them as quickly as we can without sacrificing too much information. A lot of vocabulary here, and before I get to the individual vocabulary, let's look at this picture. This is a very good generalization of what we're trying to accomplish. We're trying to understand the main idea that the population is a group of people that we're trying to find information about. It could be the school, it could be a city, it could be a nation, or the entire world. But we're not going to be able to get those answers very often, because if it's a big population, you cannot ask every one of them. If it's a small population, not a big problem, because you would just ask everybody in that population. For example, a class, maybe even a school. We do a lot of surveys in the school, and that's a population that we want information on. But most of the time the population is too big for us to ask everybody. It takes too long to ask them, or too much money to get the process done. So we would choose instead to do a sample. And a sample would be a group of that population. So instead of asking everybody, you would ask a small group of people, and hopefully that small group of people will give you the information you need. Now again, it's a small group compared to the whole, so sometimes that sample can be a good sample or a bad sample. And that's what we're going to talk about in this lesson. What's a good way to get a good sample, and what are the problems with bad samples? Because we want this sample right here to give us an idea about the whole population. So when we are dealing with the population, we're talking about the parameter, in other words, the answer. But we can't always ask everybody and get the answer, so we would instead take a sample, and we would get from that sample a statistic. And the statistic is a guess. Alright, now hopefully the sample we took is a good sample, so it's a very good guess, but still with statistics we don't have the answer. As like I said, the parameter is an answer that we're looking for. The statistic is our result from the sample that shows us an idea of what the answer might be. So what are good and bad ways of getting samples? Well, first of all, in terms of definitions, let's make sure we get a couple things squared away. The population is the entire group of individuals about which we want information in a statistical study. Alright, and you can pause this anytime if you want to write these down. A sample, like we showed below, is a part of the population from which we actually collect information. We use a sample to draw conclusions about the entire population. So if that's a good sample, that's going to give us a good idea. If it's a bad sample, we're not in luck. But there's good and bad ways to get samples. Probably one of the worst and most oftenly used example is a convenience sample. And that's a sample that is taken in a way that is easiest for the one taking the sample. So for example, if I said go get a sample and you ask the person next to you, that's not a very good sample. It is actually very convenient for you, but it gives you bad results. A step up would be a cluster sample. A cluster would be a sample that consists of items in a particular group. Now for example, if you asked a row in your class, they're clustered, they're locked together by where they're sitting. If you went to a baseball stadium and picked a section, again they're grouped together by their seating. It can still be random, but again they're locked together. If you asked a bus, then the people on that bus are grouped together or clustered together. So it's a little bit better than a convenience sample, but again they're locked together, so you have similar people in that bus. And that's an issue, because you want a good variety of possibilities in your answers. I want to jump down to a systematic random sample. That's again a step up. And that's a sample chosen by using a system or method that creates a randomness who gets chosen. So for example, if I randomly picked a person, if I took the whole school class list and I picked randomly a person from that list, and then I would go every 10th person after that, that's a system. I'm creating a system. If I walked into every room in the school and took the person closest to the door. It sounds like a convenient sample, but the system of me saying the person closest to the door creates some randomness. If you went to the lunch line and picked one person in the lunch line and then went every fourth person after that, then again that's creating some randomness. And we'll talk about randomness in greater detail also. But the system allows it to be more random. A stratified random sample is a process that tries to include certain types of people that you want in your survey. So in other words, a sample selected by first classifying the population into groups of similar individuals called strata. For example, you could say, I want to group all the 9th graders together, all the 10th graders together, and so on, or all the boys together and all the girls together. That's called a strata. You've separated them. Then, when you had them separated, you would get a simple random sample from each group. Very important. This process is very important, especially if you're on school. If you are on student council, then you'd want to get some information from every grade, not just the seniors, for example. You'd want to see how everybody felt about an activity. So you would make sure that you would have every class represented. Now, we say simple random sample quite a bit here, and maybe I should have started with that. But a simple random sample, this is a pretty intense definition here, but generally it means everybody had a chance of being picked. And that's the key to the whole thing. Everyone has a chance of being picked or asked the question. If that's the possibility, then you're going to get a good simple random sample. If you do not have everyone having a chance of being asked, then you have a problem. And we'll get into more detail on that too. So what happens if you don't include some people? If some people don't get asked? Well, then you have a chance of having something be considered biased. Okay, so a biased sample means it favors a certain outcome. So for example, if I wanted to survey you guys about technology, if you liked it or not, and then asked you to go on Moodle and do the survey, well, if some of you don't have technology or don't have internet at home, then you are not going to have a chance to answer the questions. So therefore the survey could be biased towards those that use technology. And that's something that we want to consider. Biased could also imply that it is for or against something, more so than if it was a random sample. So if you asked people if they like football and you did the survey at a football game, well, then you're going to get a biased sample because all those people are at the game. If you asked anyone in the school, or if everybody had a chance of being asked, you might get quite a bit different result. So bias is not good. Bias is something we'd want to avoid. Undercoverage and underrepresentation. Now in the example I gave about the internet, if you do not have internet at home, then I'm going to suffer from undercoverage, meaning you're not going to get a chance to answer the question. If I want to survey people in the phone book, well, the people that aren't in the phone book are underrepresented and undercovered. So these two kind of go together. So it means you have some people that aren't being asked because of their situation. They might not have a phone, a cell phone per se. They might not be in the phone book. They might not have a home. So you have to be careful about this as well. So undercoverage and underrepresentation are both bad in terms of samples, because you want to make sure everyone has a chance of being asked. A voluntary response is an example that we see all the time. If you're on Facebook or on the internet and they say answer the survey, and you just click yes or no to a simple question. Well, the problem here is that you are voluntarily giving your perspective. And this is okay, except the problem is usually people that respond to voluntary response questions have an opinion or a strong opinion, so they want to answer the question. So you usually get extremes with this one, either a lot of no's or a lot of yeses. You're not getting a good sample of people that may not care. So if you had two choices, yes, no, and don't care, which sometimes happens, you're going to get a lot of yeses and no's because they have a strong opinion about that question. So voluntary is not very good, and unfortunately that's a majority of a lot of surveys. Alright, So we have a couple paragraphs here that describe what we're trying to get into here. And statistics is the science of data. So if you collect a survey, you collect data. And from that data, you will take information from it. So this page is very important in your notes to understand where we're trying to go with all of this, with this process of statistics. It provides ideas and tools that we can use in many settings. Sometimes we have data that describe a group of individuals and want to learn what the data say. Alright, so we're going to talk about getting data, but then we're also going to talk about what we do with the data in this unit. So, very important part of the process is exploratory data analysis, getting information from the numbers. Suppose our question is, what percent of college students think that people should not obey laws that violate their personal values? Alright, to answer this question, we interview undergraduate college students. We can't afford to ask all of them, because that would be the population. So we're going to ask a sample, chosen to represent the entire student population. Alright, so how shall we choose a sample that truly represents the opinions of the entire population? Well, that comes down to statistical design and properly choosing samples. And that's a learned process, and it takes a while, but it is a good practice, and it's good to know and have information about how these things are collected. Because most of the times we don't collect the data, but we do regularly see them in papers and on the news. So how do we interpret them and so on is very important. Alright, so the mayor of a city asked the principal to select a panel of 20 students to give impressions on youth programs. The principal stands by his office and asks the first 20 students he sees. Now what do you think they used here? What method? Well, the first students he sees, definitely going to be a convenience sample. Okay, so definitely did not work very hard to get that taken care of. Now why is this a problem? Well, students that don't walk by the office are going to be ignored, so they won't be able to answer that question. So definitely students that do not walk by the office are underrepresented. Okay. What kind of sampling are these? Let's take a look at the 4 examples here. Alright, 3-digit ID, and use a calculator to generate the 20 numbers. Very random here, so definitely going to be a simple random sample. Alright, so like I said, very random for this one, so a simple random sample. Random numbers. System to pick 5 freshmen, 5 sophomores, 5 juniors, and 5 seniors. Notice that every certain group is allocated to be talked to. Alright, so therefore you're trying to get every group represented. Those are called strata. Okay, so you have a stratified random sample. Randomly picks a student from alphabetical list of all students, and then every 20 students after that student. Notice the system there, creating a system, so that's a systematic random sample. And next one, randomly picks 20 students getting off a bus in the morning. Well, notice that they're all grouped together on a bus, so that could be considered a cluster. But also, if that's just a sample, he did not have to move much, so you get this combination convenience. So cluster and convenience are pretty close when it's something like that. Are any of these biased? Well, the most biased would be D. Okay. D would be the most biased in this particular case because that's the least amount of effort and the less randomness. And who's not represented? So this is Y. Okay, why is it not? Or why is it biased? Because if you don't ride a bus, would not get asked. Okay, so you have some people missing, and that's important to understand, so it's not the best method. So I'm going to stop the first part of this recording, and then we'll come back and talk about bad sampling methods.